Hello everyone. Welcome to Electronic Arjun YouTube channel. Today we are going to see about history of Ohm's law, Ohm's law explanation, relationship between voltage, current and resistance, water pipe analogy for Ohm's law, experimental verification of Ohm's law magic triangle, Ohm's law solved problems, calculating electrical power using Ohm's law applications, limitations of Ohm's law. Okay, let we see first, history of Ohm's law. In 1827, Ohm's law was introduced in George Ohm's book The Galvanic Chain, mathematically worked out. But despite being so fundamental to the physics of electricity, this law wasn't well received by other scientists and critics at the time. The German education minister of that time considered George Ohm's findings as heresies and said that a physicist who professed such heresies was unworthy to teach science. In the years that followed, Ohm lived in poverty, tutoring privately in Berlin until he was made director of the Polytechnic School of Nuremberg in 1833. In 1841, the Royal Society in London recognized the significance of his discovery and awarded him the Copley Medal. The following year, they admitted him as a member. In 1849, just 5 years before his death, Ohm's lifelong dream was realized when he was given a professorship of experimental physics at the University of Munich. Ohm's law became widely accepted and, apart from the science of electricity, it also proved to have useful applications to the design of telegraph system, as compared to the previous law given by Peter Barlow, who had previously, and erroneously, concluded the amount of current was proportional to the cross-sectional area of the conductor. Even the modern-day theories that define electromagnetism and electric circuits fall in alignment with Ohm's law. Surprisingly, the law even works on the atomic level. Electric current through silicon wires made of 5 atoms still flows by the relationship given in Ohm's law. Okay, let we see Ohm's law explanation. One of the most basic and important laws of electric circuits is Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperatures remain constant. Mathematically, this current and voltage relationship is written as V is equal to I into R. It means voltage equals current into resistance, where voltage expressed in volts, current expressed in amps, resistance expressed in ohms. The same formula can be rewritten in order to calculate the current and resistance respectively as follows. I equals V by R. R equals V by I. Here formula can be manipulated so that if any two quantities are known, the third can be calculated. Ohm's law only holds true if the provided temperature and the other physical factors remain constant. In certain components, increasing the current raises the temperature. An example of this is the filament of a light bulb, in which the temperature rises as the current is increased. In this case, Ohm's law cannot be applied. The light bulb filament violates Ohm's law. Okay, next we have C, relationship between voltage, current and resistance. Analyzing rows 1, 2, and 3. We come to understand that doubling and tripling the voltage leads to doubling and a tripling of the current in the circuit. Likewise, when we compare rows 1 and 4 and rows 2 and 5, we come to understand that doubling the total resistance serves to have the current in the circuit. And next we have to see water pipe analogy for Ohm's law. Ohm's law describes the current flow through a resistance when different electric potentials are applied at each end of the resistance. Since we can't see electrons, the water pipe analogy helps us understand the electric circuits better. Water flowing through pipes is a good mechanical system that is analogous to an electrical circuit. Here, the voltage is analogous to water pressure, the current is the amount of water flowing through the pipe, and the resistance is the size of the pipe. More water will flow through the pipe when more pressure is applied and the bigger the pipe. Likewise, more current will flow through the circuit when more voltage is applied and lower the resistance. Next, experimental verification of Ohm's law. Ohm's law can be easily verified by the following experiment. Required components are resistor, potentiometer, ammeter, voltmeter, battery. Initially, the potentiometer is adjusted to get the minimum reading in ammeter A and voltmeter V. The current in the circuit is increased gradually by moving the sliding terminal of the potentiometer. During the process, the current flowing in the circuit and the corresponding value of potential difference across the resistance wire are recorded. This way different sets of values of voltage and current are obtained. For each set of values of V and I, the ratio of V by I is calculated. When you calculate the ratio V by I for each case, you will come to notice that it is almost the same. So V by I equals R, which is a constant. Plot a graph of the current against the potential difference, it will be a straight line. This shows that the current is proportional to the potential difference. Ohm's law triangle. To help remember the formula, it is possible to use a triangle with one side horizontal and the peak at the top like a pyramid. This is sometimes known as the Ohm's law triangle. In the top corner of the Ohm's law triangle is the letter V, in the left-hand corner letter is I, and in the right-hand bottom corner is R. If the value of voltage is asked and the values of the current and resistance are given, then to calculate voltage simply cover V at the top. So, we are left with I and R, or I into R. So, the equation for voltage is current multiplied by resistance. Ohm's law solved problems. Example 1. If the resistance of an electric iron is 50 ohm and a current of 3.2 amps flows through the resistance. Find the voltage between 2 points. Solution. If we are asked to calculate the value of voltage with the value of current and resistance, then cover voltage in the triangle. Now, we are left with I and R, or more precisely I into R. Therefore, we use the following formula to calculate the value of V. V equals I into R. Substituting the values in the equation, we get V equals 3.28 times 50 ohm equals 160 volt. V equals 160 volt. Example 2. An EMF source of 8.0 volt is connected to a purely resistive electrical appliance like light bulb. An electric current of 2.0 amps flows through it. Consider the conducting wires to be resistance-free. Calculate the resistance offered by the electrical appliance. Solution. When we are asked to determine the value of resistance when the values of voltage and current are given, we cover R in the triangle. This leaves us with only V and I, more precisely V by I. Substituting the values in the equation, we get R equals V by I. R equals 8 volt by 2 amps equals 4 ohm. R equals 4 ohm. Calculating electrical power using Ohm's law. The rate at which energy is converted from the electrical energy of the moving charges to some other form of energy. Like mechanical energy, heat energy, energy stored in magnetic fields or electric fields, is known as electric power. The unit of power is the watt. The electrical power can be calculated using Ohm's law and by substituting the values of voltage, current and resistance. Formula to find power. When the values for voltage and current are given, P equals V into I. When the values for current and resistance are given, substitute Ohm's law in above equation. Hence we get P equals I into R into I. P equals I square R. What is a power triangle? The power triangle can be employed to determine the value of electric power, voltage and current when the values of the other two parameters are given to us. In the power triangle, the power, P, is on the top and current, I, and voltage, V, are at the bottom. When the values of current and voltage are given, the formula for finding power is P equals V into I. When the values of power and voltage are given, the formula for finding current is I equals P by V. When the values of power and current are given, the formula for finding voltage is V equals P into I. Ohm's law applications. The main applications of Ohm's law are to determine the voltage, resistance, or current of an electric circuit. Ohm's law maintains the desired voltage drop across the electronic components. Ohm's law is also used in DC ammeter and other DC shunts to divert the current. Limitations of Ohm's law. Following are the limitations of Ohm's law. Ohm's law is not applicable for unilateral electrical elements like diodes and transistors, as they allow the current to flow through in one direction only. For nonlinear electrical elements with parameters like capacitance, resistance, etc., the ratio of voltage and current won't be constant with respect to time, making it difficult to use Ohm's law. Thank you for watching.